Yeah, second question you sent me, I didn't understand any of the words in it, but sure, look, we had a crack at the maths of it anyway. So you were given a function, p of v, and 4 pi times m over 2 pi rt to the power of 3 over 2 times v squared exp bracket minus e mv squared over 2rt. And then in the question you were told what r is equal to, you were told what m is equal to, and you're told what t is equal to. So the first thing you do is put in the number for r, put in the number for m, and put in the number for t. And another note here, if you see exp and a bracket, that means e to the power of. So that's e to the power of minus mv squared over 2rt. So all I did now is fill in for my my r and my t and my m and my m and my r and my t. Now I did my calculations, so I put all of this now into my calculator in one go, and that came down to 0.0375. Then I have my v squared here. Perfect. Now I needed to calculate this value up here. So I know v squared will obviously stay as v squared, so I just calculated the numbers. So I put 39.9 over 2 times 8.314 times 257, and that came out to minus 0.009, and I have my v squared there. Now there wasn't actually a huge amount of work to do in the next part. They said now, they told you how to solve this. They say you solve this getting the integral of VPV from 0 to infinity. So VPV means I have PV, that's what I just found. So VPV just means multiplying it by V. So I'm multiplying another V into my expression. So I had a V squared, so when I multiply in, I get my V cubed. Right, now they would want me to integrate that from 0 to infinity. But rather than leaving me to my own devices, they've given me some clues, which I'll go through in a second. But the first thing that I did is that the 0.03735 is multiplying my expression, so I'm popping that outside. So now I just have to integrate this from 0 to infinity. I forgot my dv there. I should have a dv, just to be correct. So they said, they gave a note there, so they said you can use this if you have the integral of x cubed times exp to the power minus bx squared, and I think that's what's in the brackets. There was something blocking it in the notes that you showed me, dx. This is how you integrate it. First of all, I'll rewrite my exp, so that's e to the power of minus bx squared, so that's what it should look like. They said if that's what you have, the integral from 0 to infinity will be this, 1 over 2b squared. So the b is the number which your variable squared. In that case, it's the b is my 0.09. So if I want to integrate this, it's 1 over 2 times b squared. So for me, it's 1 over 2 times 0.09 squared. That's the integral. But don't forget, outside, I multiply my answer by 0.03735. And when I multiply that in, I get 230.56, and I think that's in meters per second.